So here we've got some information from Statistics Canada, and the population of Nunavut is expected to grow annually by 0.8%. In 2009, its population was about 30,000, and we're supposed to estimate how much it's going to be in 2013 to the nearest thousandth. Because it's already an estimate to begin with, and we're making projections, so we know it's not going to be for sure. We can make a formula for this, yeah. So we know that our first term, what we're going to do is term 1 is 30,000. That's going to be our starting point. And if each year it increases by 0.8%, what is it going to be in 2010? What's our term 2 going to be? You don't have to use you can use whatever math you want, but let's figure this out. How much is it going to be if it increases by 0.8%? And then we'll be able to figure out 2013 from that. So this is getting back percentages. How do we increase something by 0.8%? Okay, so we have our 30,000. If I wanted to figure out what 0.08, or not 0.08, 0.8% of 30,000 is, how do I do that mathematically? Change the percentage to a decimal, which is 0.008. And a percentage of, then we would multiply that by 30,000. What do you get? 240? Is that 240? Okay. So how many people are there going to be in 2010? I changed a percentage. So if you had 10%, are you okay with that being 0.1? Okay. If you have 2%, are you okay with that being 0.02? And what's happening is that decimal place is getting, moved over, right? And so if you had 0.8%, that's going to be 0.008, because it's less than 1. Because 1% would be 0.01. And then 0.8% will be 0.008. So then in 2010, we would estimate 30,240. It's going to ask 2013, but you would have to go from there and add 0.8% to 2010. And then you'd have to add 0.8% to the next one. So we could keep doing this process from here to here, and then find term 3, which will be 2011, and then term 4, which will be 2012, and then term 5, which would be 2013. Or we could notice that we're multiplying by the same number every time. So I'm going to just do term 3 the same way. I'm going to say, well, now I'm going to have to do 0.8% of 30,240. So I decimal 008 times 30,240. $241.92 new people. Nice. You can see why this is just an estimate. And if I add that 241.92, and right now I'm not doing any rounding, I'll just keep all of my decimal places. So we have 0.92 of a person right now.
You can skip a step by doing 1.008.
Yes.
Keep the 30,000.
Good. So this is a pattern that you might have noticed with percent increase before. You may have noticed this probably with taxes, that when you add 13% taxes to things that you buy, you can do that in a shorter way by multiplying by 1.13. So if we wanted to add 0.8% to 30,000, we can do it this way by finding what 0.8% of it is and adding it. Or we can notice that once I've got these values here, to go from term 1 to term 2, if I divide this by this, I get 1.008. That's how much I've multiplied by. And if I take term 3, 30,481.92, and divide it by 30,240, I've multiplied by 1.008. And if we multiply something, the same thing over and over again, that is an R value. That's our common ratio. And so now, instead of continuing this process, we could say this is 2009, 2010, 2011, dot, 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 term 5 will be 2013. Yeah, so now we can use our formula. If we wanted to find term 5, we could say I know term 1 is 30,000. I know my R value is 1.008 to the 5 minus 1, and plug that in all at once.
Why is it a 1.008?
So anytime that we're increasing a value, when we figure out 0.008 times this, we get 240. And then to figure out how many people there would be, you would have to add your original amount that you had before to that. This is your 0.008. This is what you had to start with. So we had that's 100% or 1. Putting them together gives you 1.008. So mathematically, that's what's happening.
Why is it a power?
It's a power because if we looked at going from this one to this one and this one to this one and so on and so forth, if I wrote that out, I would have my 30,000 multiplied by 1.008 once to go to the second one. Then to go to the third one, I'd multiply by 1.008 again. And then I'd multiply by 1.008 again. And when you have repeated multiplication, you could write that as a power. And so you're going to have 1.008 4 times to go from that term 1 in 2009 to term 5 in 2013. And when we type that into our calculator, we get 30,971.6. It says to estimate to the nearest 1,000. So if I round this to the nearest 1,000, 31,000 would be an approximation. Now, in these real-life word problems, one of the things that's going to be tricky is to figure out what term these are. So if we made 2009 term 1, sometimes you'll be tempted to say 2013 is term 4. Because if you do 13 minus 9, you're going to get 4, not 5. But it's 4 later, so 1 plus 4 makes term 5. Because 2009 is included. So if we want to figure out in 2049, that's 40 years later, what term will that be? Term 41. And I've noticed in this textbook sometimes in the answer key, and I believe in question 15, there might be a mistake in the answer key, so we're going to do that one together in a bit. But let's find out part B. If we wanted to figure out term 41, 30,000, 1.008 41 minus 1 will be 40 up here because it is 40 years later. $41,261. 0.3 rounded, but to the nearest, rounded to the nearest thousand would be 41,000. Questions you can do for this one are 10, 13, 14, and 15. And we are going to do 15 together right now. So we'll start with 15.